Hey everybody, we're on 8.3, identifying the greatest common factor. All right, so again, we're going to start by doing by reviewing. If you remembered how to do this, it's just distributing. So if we distribute a 2, we'd do 2 times 5x squared gives us 10x squared. Here we'd get negative 6x, and here we'd get plus 14. All right, try and see if you can do B and C. It'd be just a good review, and we're going to be talking about that in a minute. All right, so hopefully you gave this a try. X times x is x squared, and this would give us a negative 4x. Again, we distribute everything that's multiplying the parenthesis. So here we would end up doing 3x to the 4th. So again, when we're multiplying like bases, we'll add their exponents. And then we'll do it to the next term. So that gives us a negative 6x to the 3rd. And you could put a 1 there, so 2 plus 1 is 3. And then here we'll end up getting, what's 8 times 3? 24. Okay. And we're set to go. Make sure it's in standard form, and it is, so that's great. Okay, so what we just did is distributing. Okay, but sometimes we want to do the opposite, okay, and that is called factoring. So distributing and factoring, those are just opposites. Okay. There's many different ways to factor, and we're going to start by talking about what's called the greatest common factor. The greatest common factor is the highest coefficients and or variables that divide evenly into every expression. So let's just go into a problem and see what we can come up with. Okay. So here we're going to first start talking about coefficients. So we're going to talk about the numbers in front of, or the numbers, okay? I guess coefficients and constants. Okay. So we want to look at these 3 terms. We have a 10x squared, we have a negative 6x, and we have a 14. And we want to know what is the greatest common factor, or what's the greatest number, since we're just going to talk about numbers now. What's the greatest number that we can divide all 3 of those terms? What can we divide 10, 6, and 14 by evenly? All right, and we don't want just any factor, any number that we can divide it by. We want it to divide it by its greatest, the greatest number that can go into all 3 of those. So like 1 goes into all 3 of those, but it's definitely not the greatest, okay? How about the 2? Can 2 go into 10, 6, and 14? Yes. Okay. Can anything else go into that larger than that? Probably not. So we'll say our greatest common factor here is 2. One way you can do this, another way, this is how I taught it last year. I don't think I'm going to do that at all. I tried to make the numbers a little smaller so that you could just look at it. But one way you could do it is to write down factor pairs, okay? So things like 1 and 10, 2 and 5, 3 doesn't go into 10, 4 doesn't go into 10, and then we're back to 5. So these are all the numbers that can divide 10 by. And then you can do it with the 6, so 1 and 6, or 2 and 3. Those are the only numbers that divide 6 by. And then for 14, we could do 1 and 14, 2 and 7, and that's it. So here we could look at all of these numbers and see what is the highest number that we can do for all of them. So we have our 2's, we have 1's, and we have 2's. There's nothing else. 5 doesn't go into the others. 3 doesn't, 7, that's it. Okay, so that's always an option if you're ever stuck and not sure what the greatest common factor could be. Okay, So pause and see if you can come up with B, C, and D. Okay, so here we have 4 terms that we want to look at. We have 15, 5, 20, and 3. Okay. The only thing that can go into 5 is 1 and 5. So if there is a greatest common factor, it's got to be 5. So 5 goes into 15 and it goes into 20. So here our greatest common factor here would be 5. Okay. What about this one? What can go into 27 and 30? So maybe you're not sure. You could try and write down like factor pairs. So like 1 and 27. Looks like maybe 3 and 9. 4 doesn't, 5 doesn't, 6 doesn't, and 7 doesn't. So those are the only things that can go into 27. For 30, you could do 1 and 30, 2 and 15, 3 and 10. And one way to do this is you could just take your calculator and start dividing by numbers and seeing if it goes in evenly. Okay, 4 doesn't go into 30, 5 does, so 5 and 6, and now 6, we already have 6, so we've covered everything. So the highest number that goes into that, we have a 1, and we have a 3. So 3 is the highest number that can go into 27 and 30. So our answer here would be 30. Okay, for D, this is another thing I would always suggest, to start with your smallest coefficient, because that kind of limits how many things you can divide by. So the only thing that can divide 2 by is 2 and 1. So does 2 go into 8? Yep. And does 2 go into 4? Yep. So our greatest common factor here is 2. All right, we can also factor out, the greatest common factor can also be variables. Okay. So every term, well, I don't know, I want to read that, but let's just talk about it. So looking at this example, how many x's could we take? So there are 8 x's here. There are 6 x's here. What is the most amount of x's that we could take from both of those terms? Okay, it's a 6. So we have 6 that we could take in this term, and we could take 6 from this term. All right. So here the greatest common factor for these variables would be x to the 6th. Okay. If it helps, we can expand that out. We could say here we have 8 x's, and we have 6 x's. So how many can we take from both? Well, we could take 6 here, and we can only take 6 here. You can't take 8 because there's not 8 x's in our second term, if that makes sense. So generally, your greatest common factor for your variables is always going to be your smallest exponent. Okay, so looking over here, how many x's can we take out? Well, we can only take out 3, because that's the most that we could take from this term. We can take 3 from here, we could take 3 from here, because there's more than 3 there. So the greatest common factor here would be x to the 3. All right, what about this one? Pause and give this a try, and try D as well. So again, here, our smallest exponent here is a 2. So that means we can take 2x from each of those terms. So here would be do x squared. Again, this is not in standard form, but for that one, it doesn't really make much of a difference. Okay. If it was standard form, like these first two, the exponent is at the very end. But if it's not in standard form, you still need to look at the exponents and make sure that you're choosing the smallest. So here the smallest is y to the 4th, which means we can take 4 from the 7 and we can take 4 from the 5. Okay, so here our Greatest common factor here for the variables is 4, y to the 4. All right, we also need to talk about leading negatives. All right, it's going to make a lot of it's going to be very important when we get into our next unit is to handle this. If the first term is negative, that sign, the negative, is part of your greatest common factor. Okay, so if we look at this example, we have negative 2x squared minus 4x plus 6. Okay, if we want to try and take out the greatest common factor, we want to look at the numbers. So we have a 2, a 4, and a 6, which means we can take out a 2. And since our leading term is negative, we need to have that be part of our greatest common factor. And this is another reason why it's really important to put your terms in standard form, because I think we'll probably have an example here, okay? If you look at these numbers, okay, what's the greatest common factor for 3, 2, and 7? Well, the only thing that goes into that is 1, so we can't factor out any of our greatest common factor is just 1, okay? So you could write 1. We'd look at the variables and would say, well, we have a b squared, we have a b to the 4, and we have a b to the 1. So the smallest here would be a b to the 1, or just a b. Okay, so I think we're pretty good for that. But then, do we have a leading negative? Is our first term negative? Well, right now it's not, but it's not in standard form. Your equation should, before you do anything, should put this into standard form. So highest exponent first, and then our 3b squared is our next, and then we have our minus 7b. So here we do have a leading negative, and we'll want to put that as part of our greatest common factor. All right, so keep that in mind. It's one of the most common mistakes, and it will mess things up in the future. All right, so now we just have a couple more examples doing it all together. So we're going to need to check for numbers, variables, and a leading negative. Make sure it's in standard form first. So this is in standard form. We have 8. We have our 8, and then a 6, and then a 2. So standard form, check. And now we want to say, what's the greatest common factor for the numbers? So what can we divide 8, 4, and 16 by? Well, that would be a 4. This will be a place where you could also make a common mistake, is you would say, well, I know that 2 goes into 8, 4, and 16. And you may think that's the greatest common factor, but in fact, it's 4. So again, if you ever want to check, you can always write down factor pairs like 1 and 8, 2 and 4. And those are all of them for 4. Here you could do 1 and 4, or 2 and 2. And then for 16, you could do 1 and 16, 2 and 8. 3 doesn't go in, 4 times 4. And that's everything. So you could look at these and say, well, the highest here is a 4, and a 4. So our highest, or our largest factor is 4. Okay, and then we'll look at our variables. So we'd look at the 8 and the 4 and the 2. Our smallest here is a 2. So then we would say m to the 2. And you've got to look at the exponents for every single one. Let's see, do we have an example of that? No. Okay, so we need to talk about that real quick. Maybe we'll change it for the next one. We'll do our next one, we'll change it up a bit. Okay, and then we look for the leading negative. So this is in standard form, there's not a negative, so this is our greatest common factor. Now let's look at this example, okay? This is in standard form, but let's add a constant. So let's look at the numbers first. So we have 6, 2, 10, and 4. The greatest thing that you could divide all of those by is a 2. We can look at the variables. So we have a 5, a 4, a 3, and this would be like a 0. Okay, so here we can take out we can't take out any of the x's, okay? So keep that in mind. I should have had more examples of that, okay? If we have a constant, we can't take out an x. I mean, we could take 3 x's from this term, and this term, but there's no x's here to take. So keep that in mind when you do your homework, okay? So we can't take out any x's, and again, I just put this in for an example, okay? And then we do have this leading negative, so our greatest common factor would be a -2. All right, give C and D a try, and then you'll be done, okay? All right, so we look at the numbers. We can divide both of those by 3. We look at the, I made a mistake, okay? I did not put it in standard form first. So we want to move this over here. So we'll do -12x to the 6th plus 3x to the 3rd. Okay, this is going to make the difference because now our highest exponent, its coefficient is negative. So we're going to take out a negative. We're going to take out the greatest common factor for the numbers, which was a 3. And then the smallest exponent here was x to the 3rd. So we can take 3 x's from here, and we have 3 x's that we could take from there. And then this last one, again, this is not in standard form, would need to move this over here. So you would maybe think that we have our leading negative is part of our greatest common factor, but it's not in standard form. So we can look at our numbers. We could divide by 7. We look at our smallest exponent is a 4, so y to the 4. And then our leading term is positive, so we don't need to write down the negative. All right, so if you have questions, let me know. Our next lesson, we're going to take out the greatest common factor, and we're going to have what's left. We're going to write down all the stuff that's left behind. Okay, so work really good on understanding and identifying the greatest common factor, and it will help you a lot on our next lesson. All right, we'll see you later.